Today we are going to be solving systems of equations by elimination. So let's take a look at the first problem we have. Here we have 2x plus y equals 3. Negative x plus 3y equals negative 12. So it's set up for elimination because our x's, our y's, equal signs, and constants are all in line. Our problem is, though, we can't just add these together the way they're at, because if I do so, I end up with x plus 4y equals, and add this stuff together, I end up with negative 9. That doesn't help us. You see, the whole idea behind elimination is to eliminate one of the unknowns. So what we'd have to do is change one of the equations so that it will eliminate a variable. So let's take a look at what we could change. Well, we could either cancel out our y's or x's. Here, we can almost about cancel out our x's because they're opposite signs. I just need this term here to be a negative 2 rather than a negative 1. So let's do that. Let's take this equation here and let's multiply it by just 2. So every number there gets multiplied by 2. And I'll go ahead and rewrite what I've got. So it becomes a negative 2x. It becomes a positive 6y, and I need to make sure I multiply this term as well. It's negative 24. So let me take the original equation, original first equation, just move it down below. So 2x plus y equals 3. And now I can add them together because I end up canceling out the x's. See, now those x's are gone, and I can rewrite the equation, and I only have one unknown. So I have just 7y equals negative 21. And so when I go ahead and solve for y in this case, I end up with a y value of negative 3. So that's my y value. I still need to substitute in and solve for x. So I'm going to take this negative 3, and I'm going to put it in place of y in the equation above. And so I've got now 2x plus y. But in place of y, I'm going to put that negative 3, and this all equals 3. And so now we've got to do some opposite operations. Move this negative 3 to the other side, so I'm going to do an opposite operation, which is positive 3, so add 3 there. And now I've got a 2x equals 6. So from there, I just have one step, and that is to divide by 2. So you do that on all sides, and there we have our x value. So x equals 3. So we've got it. Well, that's the ordered pair, 3 comma negative 3. So these problems require a little bit of extra thought in what you want to cancel out. So same thing here. Again, we can't just add the equations because we don't eliminate one of the unknowns. So here I could multiply either this top equation by 3 or the bottom one by negative 2. It doesn't really matter which one you do. So I guess I'll go ahead and multiply this top one by 3. So all these numbers get multiplied by 3. And that's the part sometimes people will forget to do, is to multiply each of the numbers by the value to cancel out one of the unknowns. So here I end up with 3x. 2 times 3 makes 6y. And 11 times 3 makes 33. So now I can add them together to cancel out that x term. So I still have a y term here. And when I cancel this out, I end up with a 7y equals, now here I have to subtract, and when I do that, I end up with a positive 28. And so oftentimes people will make the error on that subtraction there, so make sure maybe you put the bigger number on top when you do it. And then that shows you that you have to end up borrowing. And so I have to borrow from the 2, changes to 13. That makes 28. Anyhow, we go ahead and do the division, and we end up with y as 4. So once you've done that, you can substitute that value of y back into one of the equations. I'm going to put it into that original equation, the top one, before I modified it. And so I'd rewrite it as x plus 2 times by y. But y is 4, and this should all equal 11 at the end. And so we go ahead and multiply that, and we have now x plus 8 equals 11. Subtract the 8, and we'll have our value of x. So x ends up equaling 3. So there it is, 3, comma 4. So remember, it always goes x and then y in the ordered pair. Well, a couple more examples. C and D are a little bit tougher than A and B in that here we just can't multiply one of the equations to cancel out one of the unknowns. Here we're going to end up having to multiply both equations. So we just have to take one of the variables and try to cancel them out. Let's go ahead and try to cancel out, how about our x terms in this case? So if I want to cancel out x, I need to make sure I have a 2 and a 5 as a factor. So I'm going to multiply by 2. And then down here, I'm going to make 10x, negative 10x. So I want to make this x term positive 10x. So I'm going to multiply it by 5. So each of the numbers on that bottom equation get multiplied by 5. Let's go ahead and rewrite what we've got then. It's going to become a negative 10x, a positive 4y, and this will all equal, if I double each of those numbers, that makes 64. Down below, I go ahead and multiply this, I get 10x. I get a positive 15y, and I multiply 5 and 10, I get 50. So now I can add these equations, and I'll get those x terms to cancel. So let's see what we've got left over. Here I cancel out my x terms, and I see that I have 19y, and this all equals, and then when I go ahead and do this work, I end up with 114. So I had to 4 and 0 make 4, and this makes 11. So big numbers there. Well, let's see, hopefully the 19 goes evenly in there. And as I'm thinking about it, okay, I'm pretty sure it's going to go in evenly because this is a book problem. And 9 times 6 makes 36, but I need to make a 4 at the end. So I'm thinking, 9 times 6 makes 54. So that does end up working. I was thinking of 4 times 9 when I said that. So 19 times 6. Let me try that and see if that ends up equaling 114. So this makes a 54, so that ends in a 4. That's good. And then I add the 5, and 6 and 1 makes 6, plus 5 makes 11. So that does end up working out. So y does equal 6. So now I'll take that 6 and put that back in for y, probably into this top equation here. So I'll just stick it right there and rewrite the equation. It's going to be a negative 5x plus 2 times by 6 equals 32. So we go ahead and do some work there. Negative 5x plus 12 equals 32. And we can do some opposite operations and see what we get left over. So I'll subtract that 12 from all sides. And here's what we've got. We've now got a negative 5x equals, and this ends up making 20. So we divide by that negative 5, and we've got our value. X is negative 4. So there it is. We'll write the answer up here. Negative 4, comma 6 is what we ended up coming up with. Well, one more problem like that. So let's take a look at it. Well, in this case, we can either cancel out x's or y's. I'm going to stick with the smaller numbers here. So I'm going to multiply maybe this top equation by 3 to cancel out the x term. Bottom equation by 2 to cancel out this x term. So let's go ahead and do that. And again, I could have multiplied this one by 4, this one by 5 to cancel out the y's. It doesn't really matter. Either way, as long as you cancel out one of the terms, you'll be able to solve for the other. So I'm just trying to keep the numbers small, so I'm going to multiply 3 times the top equation, and we'll go with a 2 times each of the numbers on that bottom equation. So let's go ahead and rewrite what we've got. So my new top equation is going to be 6x plus 15y equals, and then if I multiply this out, I remember to carry, so I end up with 78. And then on the bottom equation, it makes a negative 6x, it makes a negative 8y, and this all multiplies to make negative 50. So again, the important thing is to multiply every number. That's the part people will mess up on, and then also being really careful with the signs. So now we can go ahead and collect some terms. Again, we get these x's to cancel. It's the whole idea here. That's why they call this elimination. And we have 7y equals, and then this I have to subtract because they're opposite in sign. So it makes 28. So when I go ahead and do the next step, I'm going to divide by 7 here. And I end up with y as 4. So that gives me my y value. But we're not done yet. We still need to substitute back in to solve for x. So I'll do the top equation there. So I'm rewriting this top equation, 2x plus 5y. But instead of y, we put 4. This all equals 26. So we go ahead and do some work there. Again, we bring down that 2x. Multiply the 5 and 4, we get 20. And this all equals 26. So from there, we can go ahead and subtract that 20 from both sides. So minus 20, and that leaves us with, rewrite the equation up here, 2x equals 6. So 2x was left over. Subtract these, I get 6. And so just one more step, and we've got our answer. So divide by 2, and x is 3. So there it is, 3 comma 4. So that gives you an example of how to do two different types of problems with elimination where we have to multiply one of the equations by a number, or sometimes we'll end up having to multiply both equations by some number. And so this method works really well. It makes the problem, at least to solve for one of the unknowns, go very quickly. The other unknown we still have to substitute back in for. So the next part we'll deal with some word problems involving elimination.